Hey everyone. So we're going to do a few application problems today for this video. They're just go in your notebook, and you might want a calculator. That would be helpful. So what I want you to do is actually copy this problem down. So pause the video, copy it down, and then we'll start doing it. So we've got a theater, and it has 13 seats in row 1, 15 in row 2, 17 in row 3, etc. So, I mean, if you can kind of picture like a theater, there's the stage, and then the first row has 10 seats, and then, 13 seats, and then 15 seats, and then 17 seats. Okay, so the first question says, how many seats in row 25? Well, it would take a long time to draw this out and continue, to add that all up and to figure out what that would be. So we want to use one of our sequence formulas. So we had two. We had arithmetic, which was an equals a1 plus n minus 1 times d. And we had geometric, which was an equals a1 times r to the n minus 1. So first we have to figure out which kind this is. And if you notice the patterns, 13, 15, 17, we're adding 2 every time. So this one's definitely arithmetic. So I'm going to use that arithmetic formula here, and we're going to write a sub 25 equals, I need my first term, which is 13, plus n minus 1, well, n is 25, so 25 minus 1, times the common difference, d, and that's 2, because we're adding 2 every time. And then I just do the math here. So let's see, that's 13 plus 24 times 2, which is 13 plus 48, which is 58, 61. So 61 seats in row 25. Part B says how many seats in row n. Well, then it's not asking for a specific row, it's asking for the nth row. So here we go, a sub n equals, and instead of plugging in an actual number, we just keep it as n. So I keep 13 for the first row, plus n minus 1, because I'm just going to keep it in terms of n, times the common difference of 2. This is just like we did the other day, and then we're going to distribute the 2. So we get 13 plus 2n minus 2, which gives me a final answer of 11 plus 2n. So that formula could find the number of seats in any row. Next problem. Here we've got a little diagram, some Legos. If this pattern is continued, how many Legos units will be in the 15th shape? So first we sort of have to figure out what the pattern is. So I'm going to go ahead and call these. We'll call the first one A1. Second one will be A2. Third one will be A3. So let's figure out how many are in A1. 1, 2, 3, 4, 5, 6, 7. How many are in A2? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3 more. Let's see if that continues. A3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. So yes, it looks like we're adding 3 every time. And if we look more closely at it, we can see that each time we're adding a new one at the top, a new one on the right, and a new one on the diagonal. So it's going to be 3 new ones every single time. Oops. A new one on top, new one at the diagonal, new one on the edge. So 3 more every time. So if I'm going to write my formula, or to figure out the 15th shape, I need A15. So we'll go A15 would equal first term, which is 7, plus n minus 1, 15 minus 1, times the common difference of 3. So that would be 7 plus 14 times 3, 7 plus 42, which is 49. So in the 15th shape, there would be 49. It doesn't say it here, but let's do it. If it was for the nth shape, to find the number of Legos in any of these shapes, we would just keep n in the problem. So 7 for the first term, plus n minus 1 times common difference of 3. And if we distribute that out, we get an equals, that'll be 3n minus 3, so that'd be 4. 7 minus 3 is 4, plus 3n. All right, one more problem. We have another diagram here, and in this one, we have smiley faces. how many smileys in the 8th group if the pattern continues, okay? And it's actually numbered for us here, so first one has 2, and then 6, and then 18, and then 54. So A1 equals 2, A2 equals 6, A3 equals 18, A4 equals 54. So we can kind of tell that that's definitely not adding, that's multiplying, and we're multiplying by 3 every time. So here, I need a geometric sequence because we are multiplying. Geometric, which is a formula, remember, is an equals a1 r to the n minus 1. So here in this problem, I know that a1 equals 2 and r equals 3. So if I want to find the 8th group, I'm going to set up and solve a8 equals 2 for a1 times r is 3 to the 8 minus 1, which is 7. So on your calculator, you're going to type in 2 times 3 to the 7th, okay, and that's a pretty big number. You should get 4,374. That's a lot of smiley faces. Okay. So that's all for this video. We'll practice a lot of these in class. Thanks.